Welcome to Study Loop.
Let's go ahead and write out the form of the partial fraction decomposition for the functions given in part A and B. So looking at part A, I see that there's a quadratic in the denominator, so it really depends on whether or not this thing factors. So first we see if we can factor it, and this one does factor. So we have here x plus 3, x minus 2. And then this is what the book would call case 1. You have distinct linear factors in the denominator, and so the partial fraction will be of the form a over x plus 3 plus b over x minus 2. And we're asked to not determine the numerical values of the coefficients, so we can stop here. We don't need to say what a and b are equal to. Now for part B. Well, first of all, numerator and denominator have equal degree, so we will need long division. Let's go ahead and set that up. Also, at some point, we'll need to know whether or not this denominator factors. So we should use a test. We should look at the discriminant here, b squared minus 4ac, where the a, b, and the c are coming from just a generic polynomial. So as the book mentions, the polynomial won't factor over the real numbers if b squared minus 4ac is less than 0. So let's check this. In our case, a equals b equals 1. These are the coefficients in front of the x squared and the x. C equals 6. So b squared minus 4ac is just 1 minus 4 times 1 times 6, and that's less than 0. So this thing will not factor, so we'll come back and use this fact later on. Now coming over here to the long division, x squared over x squared is 1. Go ahead and multiply the 1 to the x squared plus x plus 6. And then we subtract. And we get negative x minus 6. So this tells us that we can write part B as 1, the quotient, and then plus the remainder, which is negative x minus 6, over the original denominator. Now, we would use partial fraction decomposition at this point, and we know that the denominator doesn't factor because we looked at the discriminant, b squared minus 4ac was negative. So this is what the book would call case 3. We have just one distinct quadratic form that doesn't factor, and it's not repeated. It's only being raised to the first power here. So the partial fraction decomposition should be of the form, well, we have our 1 here, so let's write the 1. And then we have ax plus b. We need a linear term up there, and then our original denominator. And there's no need to find what a and b are because we are not asked to determine the value of the coefficients. But due to a coincidence from the previous line on the left-hand side, you could see that a should be minus 1 and b should be minus 6. But this circled part in the bottom right, that'll be my final answer. And that's it here.